Frying is the perfect dry heat cooking method because hot fat can conduct heat to the entire surface area of a food at one time. It's like having a pan that can just wrap itself around food. And if it's done properly, very little of the fat is absorbed into the food. Now the trick is to understand which fat to use. And for that, we need a little lesson in fat composition. You see, all fat molecules, or triglycerides, are composed of 1 unit of glycerol, an alcohol derivative, and 3 fatty acids. It's kind of like this train.
Oh no, not another one of your lame teaching aids.
Oh, don't go off the rails, Marcia. Now, let's pretend for a second that this engine and this caboose form one glycerol, and that each one of these 3 cars is a fatty acid, hence triglyceride. Okay, now each one of these fatty acids has a certain amount of seats on it, and normally these are taken up by hydrogens, okay? If every seat has a shiny, happy hydrogen in it, then this fatty acid is considered saturated. Now, fats that are high in saturates like lard, palm oil, butter, and beef tallow have a very, very long shelf life because they're stable, because all of their molecular bonds are all taken up. This is why food manufacturers really like to use them, because they add long shelf life to everything from baked goods to popcorn. And they're also easy to work with because most of them are solid at room temperature.
Yeah, what about shortening?
I'll get there.
Okay.
Okay, next card. If there is 1 empty seat on the fatty acid, then it is a monounsaturated fatty acid. Now, fats that are high in monounsaturates, like olive oil and most nut oils, are considered very, very healthy, but this seat, this is problematic, you see, because any molecular vagabond that wanders by can take that seat. And if it's something stinky, like, say, sulfur or iron oxide, then this entire fat is kaput, rancid, which is not a very, very good thing. On top of that, most of these oils are prized for their distinctive flavors, so they're not very refined. That gives them low smoke points. So again, not great for frying.
But what about shortening?
Oh, well, truth be told, shortenings are usually made from monounsaturated fats, but to make them last longer, the manufacturer adds hydrogen to the empty seat. So what was once monounsaturated is now saturated. It's shelf stable, it's solid at room temperature, but most of the health benefits are gone. Next, if there are 2 or more empty seats on the fatty acid, it is polyunsaturated. Now, safflower, canola, sunflower, and all the other oils that are big on polyunsaturates have very, very mild flavors and very high smoke points, so they are perfect for frying. But alas, lots of empty seats. These kinds of fats can go bad about 100 times faster than saturated fats. Now, you can store them properly, and that'll help things, but the biggest thing you can do to add life to your polyunsaturates is to not fry in cast iron, because more times than not, the little monsters are from iron oxide.
Well, you make it sound like all these little acids are on one big happy fat train.
That's the cool thing. There are. See, any given fat can contain all 3 of these. What separates what we call a saturated fat from an unsaturated fat depends on the combination. They can all be saturated, they could all be polyunsaturated.
Uh-huh. Okay. Well, I'm going to the ladies' room.
Bye. Time to make a break.